So now we have to discuss about the current scenario of wind energy in India, in what we are holding the position in the world ranking, how much of the potential we have, how much right now we are generating. So that few type of the scenarios of the India we have to see and we have to remember it for the exam perspective. Sometimes they can ask these values as well or the rankings as well. So be prepared for that. So currently, if you look at the India, India is the fourth highest wind installed capacity in the world with total installed capacity of 39.25 gigawatt. So this is how much we are currently generating from the data of the last year, you can say. And the highest ranking or the highest generation of the wind energy is by the China, second is USA, third is Germany, and fourth is India. Soon we will surpass the Germany because we have the huge area and huge population as well. So the energy requirement is also higher here, and we have the larger area to install these windmills as well. Then the recent assessment indicates the gross wind power potential of India is somewhat 302 gigawatt at 100-meter height. And if you suppose if you take 120-meter height, so at 120-meter height, the wind velocity would be or more and more as compared to the 100-meter. So the more would be the wind velocity, more would be the energy you will generate. Suppose if you install these wind mills in the 120-meter height, you can create 695 gigawatt of energy above the ground level. So you can see how much the difference. Only increasing the 20-meter height, you can see the more than double value you can get. And states which are suitable for the windmill installation. So the very first place is obviously Gujarat because of the coastal region we have and the desert place we have. Then the second place is for the Rajasthan, third is for Maharashtra, and fourth is for Tamil Nadu. Then we have two types of the windmills that you can see here. Both are in the diagrams right now. You can see one is vertical, another one is the horizontal windmill. Horizontal windmill that you can easily find out in all the areas of the world. So this type of windmill that you see, that is generally horizontal type of wind turbine. These are the vertical wind turbines that you can see. Here the wind movement would be from the upper surface to lower surface like this or lower surface to upper surface like this. And when this wind moves, so immediately this will revolve. And whenever this will be revolved, this is now attached to the turbine. This is called as the vertical axis wind turbine. So here the axis of the wind turbine, here you can see that is vertical in nature. And here the axis is horizontal in nature. So this is horizontal axis windmill. If you look at the power generation value of the both windmills, the vertical windmills are more efficient as compared to the horizontal windmills. So now the obvious question that you can think that why we use horizontal windmills, then why we don't use the vertical windmills? Vertical windmills are used, but that is in the very limited number. Why? Because the problematic design here. Due to the little bit of increased wind, this particular type of vertical windmills can be destroyed easily. So they cannot tolerate very high wind speed. But in the case of horizontal windmills, these are the more robust type of engineer are designed windmills engineeringly. And then in the case of vertical axis, the design is not that very good as compared to the horizontal axis. So very obviously that's why we use the horizontal axis windmills or wind turbines more as compared to the vertical axis. But suppose in the examination, suppose only about it is asking the power generation or efficiency. So remember that higher efficiency you will get in the case of vertical axis wind turbine as compared to the horizontal axis wind turbine. So this is about the two different types of windmills and the scenario of wind energy in India. So hope this is clear to you all. Now we have completed the wind energy and we have to move ahead to the next energy type, that is the tide energy or tidal energy. So as I have told you, the tides are created due to the gravitational pull of the moon. So this moon you can see here, which is revolving around the earth from this place to this place, then this place to this place, and this place to this place. Now this rotational movement is continue, and you can see that this is the new moon, this is the full moon. So here there would be no sunlight, no moonlight here, and here there would be full moonlight here in this particular portion. And these are the first quarter of moon and third quarter of moon. Now the main thing that we have to discuss here is the different type of tides which occurs in the Earth surface. Now, there are two types of tides that you can see here. That is the spring tide and there is a neap tide. Now, spring tide, it is do not related with the spring season. Okay, do not confuse it with the spring season. Spring tides generally occurs on the spring season. No, that is not true. As for spring tide and also as for strong. So always remember that. Okay, always remember that spring is correlated with the strong. It means spring tides are strong kind of tides. Neap tides are the weak type of tides. These are the weak as compared to spring tide. So obviously during the spring tide there would be high power generation. During the neap tide or weak tide there would be low power generation. So here you can see two portion, full moon to the third quarter moon and new moon to the first quarter moon. In these two scenarios, there is a spring tide situation. And in these two, new mean to neap tide, the new mean to third quarter mean, and this first quarter moon to the full moon. During this time, there will be neap tide occur on that particular region. So spring tides are formed when the sun and moon both are in line. You can see this is the inline 180-degree situation you can see with each other and pull the ocean surface in the same direction. So because these are in the new moon direction, the movement of the both the moon and the sun would be in the same direction. So there would be spring tide generation or the where there will be strong tide generation. So these leads to the higher high tides and the lower low tides. So higher high tides means more high and high value of high tides. Lower low tides means low and low value of the low tides. And such tide, which is strong in nature and which is created with the pulling effect of both sun and moon. So this type of the tide is called as the spring tide, which is strong in nature. Then there would be opposite scenario when there would be 90-degree angle between Earth, Sun, and Moon, or there would be, and see it occurs 7 days after the spring tide. The prominent point is that the sun and moon are the right angle to each other. Here you can see this is the sun, this is moon. If this is the sun, so this is his moon. So this particular area, this is 90 degree, this is 90 degree right angle you can see. So right angle to each other. And this tide occurs during the first and the last quarter of the moon. Here you can see first quarter and the third quarter or last quarter of the moon. The high tides are lower here and the low tides are comparatively higher here in the neap tides. So the total strongness of the whole tide is low here. That's why the neap tide is kind of a weak tide, which is created due to the right angle situation of the sun and moon with respect to the earth. This is, I hope, clear to you. Whenever there would be 180-degree angle between the earth, moon, and sun, so there would be creation of spring tide. Spring tide is strong tide, which is created due to the pulling effect of both moon and sun. Then we have the weak tide or neap tide, which is created when sun and moon are in the right angle from the earth. And during this situation, the low tides would be higher and the high tides would be lower, which will create a weaker type of tides. This occurs in the third quarter of moon and in the first quarter of the moon when the situation is in the right angle, and that is why the neap tide is created or weak kind of tide is created. So I hope this is clear to you all. These are the two different type of tides, which is about the theoretical portion of the tide. If you look at the examination, in the examination, this is already asked question in the examination. This is PYQ, previous year asked questions. So here the spring tides occurs. So I have told you spring is related to what? Spring is related to a strong. And when there would be strong tide creation, when there would be 180-degree angle, or you would say the earth, moon, and sun are in the single line, then only the spring tide occurs. So it is saying that sun, moon at right angle with respect to earth. This is wrong because whenever there would be right angle, 90-degree situation, there would be neap tide generation, not spring tide. At spring season, so I have told you no relation with the season, so do not confuse it. During half moon, it is also not true because half moon situation can be anything in the first quarter as well, in the third quarter as well, so somewhere in between them, so you cannot say that. Then this D option is saying that when sun, moon, and earth are in the linear situation, which is absolutely true. So this is what spring tide is. So that kind of questions are or can be asked in the examination as well. So be prepared for that theory portion as well. So I hope the spring tide and neap tide both is clear to you. So now we can move ahead, I think. So this is about the tidal cycle. Tidal cycles, as I have discussed in the initiation of this chapter as well, there is four tides takes place in day. Two high tides are there, two low tides are there, and in the 12-hour period, one tidal cycle completes approximately 12 hours. One low tide, one high tide. Then again in next 12 hours, there would be again low tide and high tide. So during 24 hours, there are total two high tides, two low tides, and total two tidal cycle. Now, the tidal cycles can be of also two types. One is called as the semi-diurnal tides, when two equal high tides and two equal low tides takes place. Here you can see high to high is same, low to low is same. So this would be called as semi-diurnal tides. Then we have the diurnal tides, when two tides by the sun and two tides by the moon produced. So because moon is very closer to the earth, the gravitational pull would be very high as compared to sun. But again, as the size of the moon is less, but the distance matters here very hugely. So here there would be difference in the tide generation. The high tide would be like this, next high tide will be like this, low tide would be like this, next low tide would be only like this. So this kind of scenario takes place because of the differential gravitational pull effect of the sun and moon. So this type of scenario is called as the diurnal tides. So diurnal, which is changing. Diurnal meaning of the diurnal is what? Meaning of the diurnal is changing with respect to time. So because the tides are changing with respect to time, this is diurnal. In semi-diurnal, the change is there, but the effect is equal here. This is called as the semi-diurnal. The effect is nullified, you can say, when there would be two equal high tides and two equal low tides. So you have to just remember these terms. So if there is any question may be asked by the UGC, you can at least answer that particular question. Then remember that the energy is generally produced only during the high tide situation, because there would be high tide situation, the water will enter into the turbine room or in the area that you have created, and when the water when come back in the low tide situation, then the turbine will run. So only during the high tide situation the or the energy is created here, you can say. So that is how energy is produced during the tidal cycle. So this line is also important. If you look at how much potential we have in the India to create this tidal energy, the potential of India, as you all know, because the lower side of the India, the majority of the area is in the coastal zone, and in the all zones the tide occurs. And during the tide, we can create energy. So potential is good in India. How much? 12,000 megawatt of electricity or energy or power you can create through the help of tidal cycle. The best places for the tidal cycles are the Gulf of Cambay in Gujarat, that is the first place. Second is the Gulf of Kutch, again in Gujarat. And the third best place is the Gangetic Plain or delta of the Sundarbans. So where again the tides you can notice there. So these are the three best places for the installation of the turbines or to harness the tidal energy. So I hope this is clear to you all.